Hi folks, this is Forces of the Universe podcast 7, 8, and 9, combining three targets. 7 is I can demonstrate graphing design. 8 is I can, using graphical analysis, identify and interpret trends in data. And 9 is I can justify and defend conclusions based on evidence. So here's an example of a graph that we'll use sometimes, and that is a line graph. A line graph is it's a line connecting points, and the points are values over time. So time is often the x-axis on a line graph. The only thing I would add to this one is labels. So we have, let's change that to purple, date on the x and the amount for the minimum wage on the y. That's a line graph. Here's another one we'll see from time to time, and that is a histogram. Histograms show the frequency of some event or quantity over time usually, but could be in response to some other variable. Over here would be the age of the population, and this axis is turned sideways, but this would be the percent smokers in the population. So this would be a histogram. You can see that males 25 to 44 have the greatest frequency of smoking in 1992. That's a histogram. By far the most useful graph when dealing with variables in science is the scatterplot. So here we have a scatterplot of height versus weight for a certain number of people, and the height would be the independent variable and the weight would be the dependent variable. So whoever was graphing this was trying to see if weight in the population depends on height. Each individual gets a single point on the graph, and then we draw a best fit line, as you see here, that shows kind of the trend. You can see an upward trend. As we would expect, as people get taller, they get heavier. And there's a little room. There's some really skinny people and some not so skinny people in this graph. Where would I give the person who made this graph? Probably only a 3 on their use of the metric system. Can you see it? Well, it's right here. You got the wrong units on weight. It should be weight in kilograms. Probably just a typo. I don't think they thought weight was centimeters. So that's one example of a scatter plot. Example of husbands and wives' ages for a certain group of people. And as expected, husbands and wives' ages tend to go up together because people tend to marry people who are about the same age as themselves. Can you see any other patterns in this data? I see one that looks like if you were to draw the line of equal ages, which is probably somewhere up about here, maybe a little lower, but it appears that in general men are a little bit older than the women they marry. So there's a little pattern in this data we can see. And that's another example of a scatter plot. I guess you would say that the person plotting this wanted to see if the wife's age depends on the husband's age, because the husband is the independent and the wife's the dependent variable. Okay, let's talk for a minute about the analysis portion. This is number 8, FOTU number 8. I can, using graphical analysis, identify trends in the data. So I'm writing out here for you a example analysis. This is a description of what we see on the graph. The graph shows that the wife's age gets larger as the husband's age gets larger. Also, the husband's age is generally a few years higher or older than the wife's age. That's an analysis of the graph. Now let's talk about the conclusion. In the conclusion, we explain the data. So what would be my explanation? An explanation would be people generally marry a spouse of similar age because we have more in common with people our own age. That would be a conclusion. So you see, I didn't just describe the data here, I actually tried to explain the data. That's what we do in a conclusion. And thank you for watching.